Welcome back, everyone. Today's session is going to be super exciting, because we're diving into multi-data source configuration using JPA in Spring Boot. Yes. 2 different databases, 2 sets of entities, 2 repository layers, and 2 JPA configurations running in the same application. This is something you will definitely face in real enterprise projects, so let's learn it the right way. I'll walk you through everything step by step, and we'll configure the whole thing live, so watch closely on my screen. In the last video, we successfully configured multiple data sources and fetched data using JDBC template. But in this video, we're going one step further. We're going to use JPA with multiple databases. Yup, real JPA with entities, repositories, and separate entity managers for each database. So before we start coding, let me quickly recap what we did earlier. Here's my application.yml on the screen. You can see we already configured 2 data sources. One for the employee database and one for the user database. In the previous video, we created an employee DBconfig class where we manually built the DataSource bean and the JDBC template bean. And the same story on the user side. We created a user DBconfig class, where we built the user data source and its own JDBC template. And along with that, we also created our employee entity and the employee JDBC repository, which used the employee JDBC template to run queries on the employee database. And we did the exact same thing for the user side as well. We created the user entity and the user JDBC repository, which used the user JDBC template to talk to the user database. Alright, before we move ahead with the JPA configuration, let's update our Spring Boot version. I'm switching to the latest one, 4.0.0, so everything we write from this point forward will be compatible with the newest Spring Boot features. Now the next step is to replace our JDBC libraries with JPA libraries, because in this video we're going to use Spring Data JPA. Alright, now let's make our employee entity JPA compatible. We already have the plain POJO from our JDBC video, but for JPA we need to annotate it properly. First, add entity to tell JPA this is a mapped table. Then at table, name equals employee. Okay, to save time, I'm just going to copy all the JPA annotations from our employee service project. We already configured that entity correctly in the previous series, so I'll reuse the same annotations. Alright, now let's do the same for our user entity. We need to make this class JPA compatible as well. So just like we did with the employee entity, I'll add the JPA annotations. At entity, at table, name equals users, at ID, and the rest of the mappings. Perfect, both of our entities are ready and JPA compatible. Now let's move on and create our employee JPA repository. Alright, the employee JPA repository is done. Now let's do the same thing for the user side. Alright, so now we've created both repositories and both entities. And if you remember from the last video, we used custom prefixes for our DataSource configuration. Because of that, Spring Boot does not auto-create anything for us. No DataSource, no JDBC template, and now, no JPA components either. So just like we manually created the DataSource beans earlier, now we also need to manually create the Entity Manager Factory and the Platform Transaction Manager for both databases separately. Spring won't do this automatically because we're using custom prefixes, and Spring Boot's default auto-configuration gets disabled. Alright, so the first thing we need to set up for JPA is the local container entity manager factory bean. This is basically the heart of JPA. So let's start by creating the entity manager factory for our employee database. I'm creating a new @bean method, naming it employee entity manager factory. Okay, to create our local container entity manager factory bean, we're going to use the Entity Manager Factory Builder. Spring Boot provides this builder, so we don't have to manually configure every single JPA property. So let's inject the Entity Manager Factory Builder into our method, and we'll use it to build the Employee Entity Manager Factory cleanly. Next, we need to tell the Entity Manager Factory which data source it should use. Since this is the Employee JPA configuration, we'll pass in our Employee data source here. Next, we need to tell JPA which package contains the entities for this data source. Since this is our employee configuration, we have to point it to the exact package where our employee entity is located. In my project, the employee entity is inside the base package, com.gan.derpun.dao.employee. So I'll pass this package name to the .packages method. And of course, in your project you can pass any package where your entities are placed. Alright, next we need to set the persistence unit name. This is important because when we have multiple JPA configurations, Spring needs a unique name to identify each entity manager factory. So for the employee side, I'll give it a clear name, something like Employee Persistence Unit. This way, Spring knows that this persistence unit belongs strictly to the employee database. Next, we need to set the JPA properties for this Entity Manager factory. These include things like the Hibernate dialect, DDL auto settings, show SQL flags, and so on. And instead of hard-coding everything here, I'm going to fetch these properties directly from our Spring configuration, the same place where we normally keep our JPA settings. So I'll inject the JPA properties object and pass its getProperties map into the builder. Alright, our employee entity manager factory is fully configured. That part is done. Now next, we need to create the transaction manager for this data source. Because remember, each data source in a multi-JPA setup needs its own platform transaction manager. Without it, Spring won't know how to manage transactions for this specific entity manager. Watch closely, I'll type it on the screen. Now to create the transaction manager, we'll return an object of JPA transaction manager. And as you can see, JPA transaction manager requires an entity manager factory object, so we need to pass in the same employee entity manager factory that we just created. Alright, that's done. We've successfully created the employee entity manager factory and the employee transaction manager. Now we need to do the exact same thing for our user database. A separate entity manager factory and a separate platform transaction manager. Alright, to save time, let's simply copy, paste the employee JPA configuration. And then we'll change only the parts that are specific to the user database. Change the bean name. This one should be User Entity Manager Factory. Next, update the data source. Instead of employee data source, I'll pass our user data source here. After that, we'll update the package so JPA scans the user entity. In my case, that's com.gan.derpun.dao.user. And finally, we need to change the persistence unit name. I'll name it User Persistence Unit, so Spring can distinguish it from the employee one. Alright, all the updates are done for the User Entity Manager factory. Now the next step is to inject this bean into the User Transaction Manager, just like we did on the employee side. Alright, that's done. We've now created the Entity Manager factory and the Transaction Manager for both databases. One for employee and one for user. So at this point, we officially have two completely separate JPA setups inside the same Spring Boot application. But here's the big question now. How does employee JPA repository know which entity manager it should use? And same for the user side. How does user JPA repository know that it must connect to the user database and not accidentally start querying the employee database? Normally, if we had only one data source, Spring Boot would magically wire everything for us. But now that we have multiple data sources, Spring Boot gets confused. It has no idea which repository belongs to which database, unless we explicitly tell it. So now the question is, how do we actually tell Spring, hey, employee JPA repository should use the employee entity manager, and user JPA repository should use the user entity manager? Spring won't magically figure this out on its own. But fortunately, Spring gives us a very important annotation for this. At Enable JPA Repositories. With this annotation, we can explicitly say, which package contains the repositories, which entity manager factory they should use, and which transaction manager they should use. So we're going to use enable JPA repositories inside each of our JPA config classes to link the correct repository package to the correct entity manager. Watch my screen. Alright, first let's open our employee DB-config class. And now we're going to add the most important annotation, enable JPA repositories. This is where we tell Spring exactly which repositories should use this employee JPA configuration. So watch carefully. The first thing inside this annotation is base packages. Here we must pass the package where all our employee JPA repositories live. In my case, that package is com.gan.derpun.dao.employee. Next, we need to tell Spring which entity manager factory these repositories should use. So here, I'll set entity manager factory ref equals employee entity manager factory. Why? Because this is the entity manager factory we created specifically for the employee database. It knows the employee data source, it scans the employee entities, and it's configured with the employee JPA settings. So by pointing the repository to this factory, we're basically saying, hey Spring, whenever employee JPA repository runs a query, use the employee entity manager. Alright, next we need to tell Spring which transaction manager these repositories should use. So I'll set transaction manager ref equals employee transaction manager. And again, the reason is simple. This transaction manager is directly linked to the employee entity manager factory, which means all the transactions created by employee JPA queries will be handled by the employee database only. Alright, it's done. Now whenever employee JPA repository runs a query, Spring will automatically use the employee entity manager factory and the employee transaction manager that we just wired. Basically, this enable JPA repositories annotation activates all the JPA features for this module. And we are telling Spring exactly how to handle them. Hey Spring, for all repositories in this package, use this entity manager, use this transaction manager, and use this data source. So everything is completely isolated and properly connected. Alright, now let's do the exact same thing for our second database, the user side. We enabled everything for the employee repository. Now we need to enable the same JPA setup for the user repository as well. Add another enable JPA repositories annotation there. And just like before, we'll update the three important things. The base packages, where our user JPA repositories live. The entity manager factory ref, pointing to the user entity manager factory. The transaction manager ref, pointing to the user transaction manager. And it's done. Now both of our data sources, employee and user, have their own JPA configuration, their own entity manager factory, their own transaction manager, and their own repository mapping. So now, employee JPA repository will always use the employee entity manager, and user JPA repository will always use the user entity manager. Both repositories are completely separate, and each one talks only to its own database. Alright, now that both JPA configurations are ready, let's integrate them into our controllers. Instead of using the old employee JDBC repository, we'll now inject the new employee JPA repository. Alright, now let's do the exact same update for the user side. Alright, everything is updated. So let's start the application. Okay, we've got an error. It says, Entity Manager Factory Builder be not found. And this actually makes sense. Remember earlier, we used Entity Manager Factory Builder to build our Entity Manager Factory. But Spring is not creating that builder bean. No problem, instead of relying on that builder, we'll remove it and directly create a local container Entity Manager Factory bean ourselves. Alright, inside our Employee Entity Manager Factory method, let's remove the old code that was using Entity Manager Factory Builder, since Spring isn't creating that builder for us. Now we'll build the Entity Manager Factory manually. So step 1. I'm creating a new object of local container Entity Manager Factory bean. Next, we'll set the data source for this factory. This must be our employee data source. Next step, we tell JPA which package contains the employee entities. Now we need to set the JPA vendor. And since we're using Hibernate, I'll create a new Hibernate JPA vendor adapter. And finally, we set the JPA properties like dialect, show SQL, etc. I'll pass in the properties from our JPA properties object. Alright, the Employee Entity Manager Factory is done. Now let's do the exact same setup for the user side. Create a new object of local container Entity Manager Factory bean. Set the user data source. Next, we tell it where the user entities live. Next, set the persistence unit name. After that, we set the JPA vendor, again Hibernate. And finally, the JPA properties. Alright, and we also need to set the persistence unit name for the Employee Entity Manager Factory, just like we did for the user one. Alright, everything is wired up. So let's start the application. Okay, the application started successfully. Let's hit the Employee API first. See? We're getting the employee details directly from the employee database, exactly what we expected. Now let's test the user API. And perfect, we're getting the user details from the user database. Both JPA repositories are now talking to their correct databases independently. Alright, let's open the console logs. Wait a second, I don't see any SQL queries here. I already enabled SQL logging in my log4j2.yml. But hey, don't worry, our multi-DataSource JPA setup is working perfectly, both databases are responding correctly. This logging issue is completely optional. If you want, you can skip this part. I'm just fixing the console log formatting so SQL queries show up properly. So our log4j2.yml is still not being picked up by Spring. So I ran mvn dependency tree to investigate what's going on. And I finally found the real problem. Multiple dependencies were silently pulling in logback behind the scenes. And remember, as long as logback is present in the class path, Spring Boot will always ignore log4j2, no matter what configuration file we create. That's exactly why our log4j2.yml wasn't being used and why SQL logs weren't showing up. So now we just need to exclude logback from those dependencies. And then Spring will load log4j2 properly. Alright, I've added all the exclusions. Now let's run mvn dependency tree again just to confirm. And perfect, no more logback in the class path. That means Spring Boot will finally pick up our log4j2 configuration. So let's start the application one more time. Yes. Now look at this, the logs are finally using the exact format we defined in our log4j2.yml. That means log4j2 is fully active, logback is gone. Let's hit the API again. And there we go. Now we can clearly see the SQL queries and even the binding parameters right here in the console. This is exactly what I enabled earlier in our log4j2.yml file, and now that log4j2 is working properly, all the Hibernate SQL logs are showing exactly as expected. Perfect. Our multi-DataSource JPA setup is working, and our logging is fully fixed. Alright guys, that brings us to the end of this video. Thank you so much for watching. If you found this helpful, make sure to like, subscribe, and hit the bell icon so you never miss our upcoming Spring Boot videos. See you in the next one.